Okay, so I don't know. We will see if it will be recorded or not. So again, thank you very much for joining this course. I hope that you will enjoy it, and it will be a good experience for you. So the course is Advanced Machine Learning with Python, but in fact, we will start also from basic. We will try to start from basic things also because it's important to understand basics in order to be able to build on top of it. So in this course, we have some learning outcomes. Point number one, we need to have good understanding of capabilities and the limitations of machine learning and the knowledge of how to formulate your problem to solve it effectively. It's very important. If you have a problem, you need to know which machine learning model we can use, for example, because today, for example, many people, they go for deep learning. It's not very important, in fact, to go for deep learning because deep learning, it's complex models and it will not help us to understand, how decisions are made. So they talk about something called explainability. And if you want to have your model explainable, I guess there are lots of models which can help us to build something to solve the problem, and at the same time also to keep this model simple, so it would be easy to understand and communicate our model to maybe end users, for example. Point number two here, we need to have good understanding of convolutional neural network, recurrent neural network, and the state-of-the-art transfer learning models. I mean, maybe we can spend here maybe 2-3 weeks in point number two. So point number one, maybe we will try to talk about different types of machine learning models, supervised and unsupervised, shallow learning. So we can work with feed-forward neural network or multi-layer perceptrons, for example, and we will use those models for solving the problems. And after that, we will deal with convnets. And the convnet, in fact, it's the same. It's a feed-forward neural network, but it has one section which is responsible for feature extraction. Because if you want to use a shallow learning model, if you want to use feed-forward neural network model for solving a problem, you need to work a little bit with the features, and you need to try to select features, what are the most suitable features for my problem. So maybe you can use principal component analysis, maybe feature selection techniques, feature engineering, and so on. But when we are working with convolutional neural network, we don't need, in fact, to do this. It will automatically extract features from your raw data. So when we are working with convnets, it's nice, it's beautiful, because we don't need to do anything, in fact, just build your model, and your model will consume your raw data, and it will be able to extract those features automatically from your raw data. So it's much easier, in fact. So working with this one, the model is complex, but it's at the same time also it helps us to solve complex problems without any headaches. I mean, we just need to feed the model with our raw data. So the model is a little bit complex and it requires more computational resources, but it's smart enough to extract features automatically and use those features and try to create mapping between inputs and outputs and try to make decision making. So for example, if you are classifying, for example, so it will deal, maybe you are working with images, for example. So it will consume those images and it will try to extract features which make sense for our problem. And it will use those features for classification. So in fact, those types of model, we call it deep learning model. Those conv neural network or recurrent neural network, it's a deep learning models, and those models are deep, which means it has many hidden layers, and those models will be able to automatically extract features from the raw data and use those features for creating a mapping between inputs and outputs and make decisions, classification, regression, and so on. So we will talk about this. Maybe we will spend it maybe 2-3 weeks, 4 weeks on that part, because this part is very important. And also state-of-the-art transfer learning. This part is very, very important because sometimes you have a complex problems, but you don't have enough data for training a model from scratch. So in this case, I don't have enough data to train a model. So in this case, we can just try to import or borrow a model which has been used in some other applications, and it has been proved that this model is good. So we will import this model, and we will try to modify this model to solve our own problem. So in this case, we don't need to train this model from scratch because I don't have enough data for doing this, but I can just import this model and try to modify it a little bit and try to customize it to solve my problem. Point number 3 here, it's effective process for developing your machine learning pipeline to tackle real-world problems such as machine vision, text understanding, time series prediction. We need also to learn something called pipelining in machine learning. This pipelining, it's a very simple term, in fact, and we will use maybe a week or less for doing this to build a pipeline. And this pipeline, it will consist of different stages or phases, and each phase will do some part from the task. So maybe if you want to work with data pre-processing, we will have a function which will do the data pre-processing for us. Maybe after that we will have maybe scalar. You want to scale your data, standardize your data, for example, normalize whatever. You can do it in your pipeline. If you want to, for example, use principal component analysis or feature selection, we can have it in the pipeline. And at the end, we will have our machine learning model, which we will do the classification part. And the idea here of using this pipeline, you can cross-validate, in fact, many things together at the same time. Because if you are writing your model in a normal way, for example, so first I will do feature, for example, normalizations, standardization, and after that I will do feature selection, correct? Maybe I will say, okay, please, I need to use 5 principal components, or I need to get the most influential 5 features, because I need to build my model with 5 features or 6 or 7, for example. And after that, you will build your model. You don't know, in fact, if 5 or 6 is the correct number. So in this case, it will be smart, in fact, to combine all those steps together with the model inside a pipeline, and you can cross-validate all those together at the same time. So in this case, we can just cross-validate all those choices which you selected, and you can see how it will impact the accuracy of your model. Also, using this pipelining, we can use something called the grid search, for example. So imagine that I want to use principal component analysis, and I want to select, maybe I want to try 5 principal components, 8 principal components, and 10, for example. So if you will not use a pipeline, you need to repeat this process several times, correct? But if you can put all those stages in the pipeline, you can cross-validate the whole pipeline against those numbers, right? So we can call it, we can call those numbers, so anyway, you can just validate, it's hyperparameters, in fact, hyperparameters of your model. You need to select it by yourself. A number of features, for example, which you want to work with, maybe a number of hidden layers. You will build a model. The model consists of number of layers. So you can say that, okay, I want to test my model with 2 hidden layers, and I want to test it also with maybe 3 hidden layers, 4 hidden layers, correct? So in this case, if you want to do this, you can put all those stages in a pipeline, and you can cross-validate this pipeline against all those variables at the same time. So it will be time consuming in coding, so it will take time, but at the end it will give you the optimum set of hyperparameters which you need to use in your code. And it's nice because maybe you are writing a paper, for example, and you can say that, okay, I will select 5 principal components. So and you got very nice results, and you will send it for reviewers. Maybe one reviewer will ask you, why not 5? For example, 6, 7, 8, 3. Why 5? So there should be justification, in fact. So if you will choose using 5 principal components, there should be a justification. And the best way to do this justification is to just use a grid search, and you can test multiple values. So I can test maybe 10, I can test 5, I can test maybe, for example, 3, 7, correct? So in this case, he will calculate the accuracy for those 4 choices, and you will select the one which will give you better accuracy. So you can just say, okay, we've been testing this and that, and we selected 5 because 5 is the best choice for us. It gives us the best model accuracy, for example, classification accuracy. So it would be nice if you can build this pipeline. Building this pipeline, it's very, very simple, and it will make life much easier. And if you want to use grid search for optimizing or for selecting different combinations of hyperparameters, you can do it easily. And if you want to cross-validate the whole model, it will be very easy. So using pipelining, it's very smart. Also, we need to develop skills which are required to deploy, monitor, and evaluate the machine learning models, as well as assess its relevance and the uses of different machine learning models. We need to know the difference between different machine learning models. Which one should we select for our problem, for example? We need to assess its relevance. if you are working with text, if you are working with time series, so which model should we select, for example? So we need to understand this, and also the deployment. If you want to deploy your model and monitor the performance of your model, we need to know this. Also, maybe from data also, we need to know the basics which are required to collect, process, and utilize data efficiently. Because sometimes when you are working with real-world problems or collecting raw data, there are some missing values, for example. So we need to know how to fix the data set so we can use it effectively for training our model. So at least we need to understand we need to know how to upload data from an Excel file, correct? And try to fix it, for example. So if you have missing values, you need to fix it. If you have some categorical variables, you need to replace it with some numerical values, because my model cannot deal with text in reality. So even if models which are working with text, it does not understand the text. We cannot feed it with text, but we need to feed it with numerical values, with numbers. We need to know the basic skills which are required to select maybe the right platform to deploy your model. Some people want to deploy the model in the cloud, for example, on an edge device, for example, or hybrid. So how to configure it to achieve the required performance. Also, the ability to document and communicate your results of your machine learning approach and guide your coding and the machine learning effort in the right direction. We have a problem. In fact, many students, they did fantastic job. In fact, they are very good in coding, but they don't have good documentations, and they cannot communicate the results from their model very well with the readers. You are writing papers, so you need to know how to communicate your results effectively, in fact, with your readers or with the evaluators of your thesis or your paper, for example. So it's very important to have to talk about validation process. We can start from the data. We have those data. Maybe we can get some statistical description of the data, for example. It would be nice if you can put this one in your paper, for example. So you can talk about materials and the methods. This is my data. This is my model, which I will use, for example. And after that, you can say, okay, we collected the data from that place. The data has those characteristics. Explain it. Try to visualize it. Try to provide a table with some statistical description of your data, for example, minimum value, mean value, max value, maybe standard deviation, and so those numbers are very important. And after that, for example, you can do normalization or standardization, for example, for your data, you need to mention it. And after that, he will talk about model selection or number of models. We have been testing a number of models, or an ensemble of, we will use ensemble learning where we have number of models in my ensemble. And the validation protocol, you need to talk about it. So how you will train your model, how you will divide your data for training process, because some people, they can just use the whole data for training the model and they cannot test the model. They will provide the results of the training, which is not correct. We need to divide the data into one part for training and one part for testing. And when we're communicating our results, we need to mention those details. And we need to evaluate the model against my test set, and we need to communicate those results to people. I mean, this is very important, not the training set, but with the test set. So, and when we try to evaluate the model also, there are many ways, many numbers which we need to get. We need to get maybe accuracy, maybe loss, correct, F score, correct. We need to have confusion matrix, for example. This is very important. If it is classification problem. So in this case, we need to have confusion matrix. So there is classification report which you need to get. It will generate all those numbers. So in fact, when you are working with Python, you have very small commands. When you are using those commands, you will be able to get all those numbers. So it's very important to get those numbers, put those numbers in your thesis, try to explain it. For example, false positive, false negative rates. Those are very important. You need to talk about it, right, in the discussion part. So if you want to compare between two models, so imagine that you are testing your data against maybe 2-3 models. So you need to know how to compare between the performance of 3 models, right? Because sometimes numbers are not enough, in fact. So maybe one model will tell you, okay, I have better accuracy, overall accuracy, but this is not correct. It might be correct, it might not be correct, in fact, because maybe you have another model which has less overall accuracy, but it performs much better for each class, for example. Or maybe we are interested in one class, for example, so we need to focus on one specific class. So there are many numbers we need to understand, and then when we are comparing, we should not compare only numbers. Yeah. Um, Yes, so the course content, we will start by learning modes, for example, and in this learning modes, we need to understand the difference between supervised learning and unsupervised learning, for example. We need to optimize to minimize error and maximize accuracy. I mean, when we are training our model, in fact, we select an optimizer, and this optimizer will try to adjust the model weights in a way which minimizes the maybe prediction error and maximizing the accuracy. So in this case, we need the error to be differentiable. I mean, we have an error function. We need to define a loss function, and this loss function, my optimizer will try to minimize it. So this error function must be differentiable. Otherwise, we will not be able to adjust the weights. So we need to have a differentiable error function or objective function, which we need to minimize or maximize. If you are focused on prediction error, so we need to minimize prediction error. If you want to focus on prediction accuracy, so in this case, we need to maximize prediction accuracy. We need to understand the representing data engineering features, for example, dimensionality reduction, to overcome risks such as overfitting. We have a big problem in machine learning, which is overfitting. And we have this overfitting problem when your model is very complex, is very large model, and you have very small data set. So your model, in fact, have very high large learning capacity because your model consists of large amount of weights, for example. So the model is huge. And it's capable, so it can consume small data quickly and memorize it. So this is overfitting. So overfitting means memorizing, in fact. So if your model is very tough, a very large model, very complex model, maybe this model will overfit the data very quickly because the data set is small and the model has very large learning capacity. So it will memorize the data very quickly. Model evaluation and improvement, for example, machine learning pipeline. We need to understand the machine learning pipeline, how to implement it. We need to know confusion matrix and understand the meaning of those numbers in the confusion matrix. We have something called accuracy, precision, recall. We need to understand what is the meaning of precision, recall. Also, F1 score, for example, F1 score, a type 1 error and a type 2 error. Type 1 error, it's false positive, and the type 2 error, it's false negative. So we have false positive and false negative. And the false positive, it means you have, for example, during the COVID time, you have someone, he is not COVID, right? He does not have COVID, but he did the test, and the test said that no, he is positive. But he is not positive in reality. So in this case, we can just say, call it, it's false positive. He is classified as positive, but in reality, he is not positive, he is negative. So in this case, we will call it false positive. This false positive rate, we call it type 1 error. And this type 1 error, it's error, but it's not very dangerous, in fact. So it's not very big deal, in fact, this false positive, because if you are doing testing or classifying patients, for example, maybe they will just need to take some pills and stay at home. If he is COVID, for example, so just ask him to stay at home and take maybe some medications. He is okay, in fact, he is okay, he is not sick, but he was classified as a false positive. So we call it type 1 error. So the dangerous here, in fact, is in type 2 error. You have someone who is positive and he was classified, or he or she classified as a false negative. He was classified as negative, but he is positive. So this is the dangerous here, in fact. So you have someone who is COVID, he has COVID, and you just told him, no, you are okay. So just please go to work, go for shopping, and don't take any medications, for example. So in this case, this is a problem, right? So false negative, this is a problem, and not false positive. So this type 2 error, in fact, this type 2 error, it's very dangerous, in fact. So in fact, for example, if you are working in a paper, you got a model, and for example, you got this confusion matrix. We have this confusion matrix is something like this one. So maybe this is classes. This is given classes or actual classes. This is predicted classes. So we have here true positive and he true negative, and this one will be he is classified as false negative, right? So it's like positive negative, and it will be classified as positive negative. So this one he is positive and classified as positive, And you have also some people who are negative, but they will be classified as positive, right? So we call it false positive. And you have here some people who are positive, but they will be classified as negative. So we call it false negative. So in fact, this is a problem. This false negative, this is a problem. We call it type 2 error. So it's not false positive, which is a problem. Of course, it's a problem also, but it will be more risky here. If this number is very large, it will be very risky. So for example, if you are building a model for a medical application, people will directly will try to look into this number. This number is very important. So maybe from your point of view, you have two models, and maybe the overall accuracy is good, right? Overall accuracy, it will be true positive plus true negative divided by total number of examples. So it will be true positive plus true negative divided by n, for example, right? So this is my accuracy. So we can say I have two models, and both of them, they have the same accuracy. But when you look into a false positive rate and a false negative rate, you found that one model has high false negative rate compared to the false positive rate. So both, they have the same accuracy, but this one is performing much worse. So which model should we select? So of course, we should select the one which has less false negative rate, for example, right? Because this is a problem. So this false negative rate is very, very dangerous, and we call it type 2 error. And if you are working in the medical domain, people will look into this number directly. If you are building a device for a hospital, for example, they will look into this false negative, because this false negative, it's dangerous. False negative, it means you have a patient who is sick, and you told him, no, you are okay, you are not sick. So he will not take medication, he will not be treated. You will just send him home, right? So this is the risk here. But false positive, it's no problem because you have a patient who is negative, but he was classified as a positive. So in this case, he just takes some pills on the medications until they maybe repeat the test one more time. We will start studying a perceptron. This perceptron, it's a very simple model. The perceptron, it's a very, very simple model. And maybe the most simple model ever, perceptron, we will study it. But this is the basic unit, in fact, of artificial neural network. So we will study a perceptron, and after that, we will study something called the perceptron learning rule. This perceptron learning rule, it's the optimizer, in fact, which will adjust the weights of this perceptron to converge. So we will study perceptron and the perceptron learning rule, and after that, we will study artificial neural network. And artificial neural network or multi-layer perceptrons, it's just multi-layers of perceptrons from this one. So it's artificial neural network, and some people, they call it multi-layer perceptrons, MLP, multi-layer perceptron. So we will study multi-layer perceptron or artificial neural network. In the multi-layer perceptron, it's just an extension, in fact, of the perceptron, just the extension of it. So it's multi-layers, so it's number of layers, and each layer consists of number of perceptrons. And of course, when we need to train this artificial neural network, we cannot use perceptron learning rule anymore, because this perceptron learning rule, it's designed, in fact, for adjusting the weights of a single perceptron. But if you have MLB, multi-layer perceptron, so in this case, we need to find another optimizer. We need to find another way for adjusting its weights. And in this case, we will use error back propagation. So to train this artificial neural network, we will use error back propagation. We will use error back propagation, which is very nice and very smart algorithm, which is used for adjusting the weights of the artificial neural network. In fact, it is used for all deep learning models, this error back propagation. We use error back propagation for all artificial neural network models, different types, shallow learning and deep learning, and so on. After finishing that part, we will try to go into training deep learning models. So we will go to this convolutional, maybe deep neural network. It's the same as artificial neural network, but it's much deeper, right? So we will study artificial neural network, and this artificial neural network, maybe we can use error back propagation and adjust it when it has maybe 2 hidden layers maximum, for example. But when it has more hidden layers, we can call it it's deep neural network. It's deep. Deep means we have more hidden layers. We will study convolutional neural network. And as I told you last slides, convolutional neural network, it's a very, very good tool for working with raw data. It can work with images, numbers, text, but of course we need to convert text into numbers. And of course, images and videos, it's numbers, its pixel value is a number. So it has very nice function to deal with raw data and extract features automatically from the raw data. And after that, we will study recurrent neural network. Recurrent neural network, it's a very smart tool which can deal with sequence of data or time series. So when your data is in sequence, correct? Sequential data, when your data is sequential, and the time series, for example. So in this case, we can just use recurrent neural network. And also we can, in fact, we can try to integrate recurrent neural network with convolutional neural networks. So we can integrate them together to provide better performance. After that, we will talk about some advanced transfer learning models. There are lots of models which are just people are using it. And those models are already trained on some other data sets. And the idea here is to try to import it from its original application to my own application. So for example, I can import a model which is trained to classify images into 1000 classes to my application, where I'm classifying into 2. So in this case, we need to do some modifications, small changes, to apply this model to my data set. My data set is different, but it's images. So if your data set is from the same domain, I have object and I need to classify those objects, so I can try to search for a model which has been trained for something similar, and I will modify it and I will transfer it to my own problem. Maybe at the end we will look into GPUs, cloud computing tools, and so on. I mean, for this book, in fact, I prepared my slides from many different sources. So some of those sources are in front of you here. So we have this nice book. It's called Deep Learning for Vision Systems, for example. This book, it's feature engineering, for example, deep learning with Python, machine learning in action, introduction to machine learning with Python, deep learning. So there are many nice books. I mean, those publishers, in fact, they are very clever because they write their books in a nice way, and they provide also good examples for people to understand things and to try it. So if you need to read, if you want to buy a book, for example, you can just look into those options. The course material, we have this link. If you want to, I mean, this is the course website at NTNU. It's Advanced Deep Learning with Python, or Avancert Emnar in Deep Learning in Python in norsk. So this is the course link. And as you can see here, the course, it's a 7.5 study points, and it's PhD level. And the exam will be teaching approach. It will be like 5 hours each lectures. Sometimes we can just 5 hours, 3-4 hours. It's according to the situation, for example. And the evaluation of the course, it's called the map-vurdering. Map-vurdering, it means it's a portfolio exam, for example. So you just need to submit some home assignments or some projects. So, but in our case here, I prefer that we will combine those small home assignments into one large home assignment, which can be used in your PhD, for example. So in your PhD, if you are working with some data sets, you can try to bring the data sets to the classroom, try to develop some models. We will study simple models from in the first maybe 2 weeks or something. And after that, we will go to more complex models. So my idea here is to bring your data set and try to apply those models. And when we study a new model, you can just apply this new model. And at the end, you can make comparisons between performance of different types of models. And you can write a paper. So the idea here is to write maybe a conference paper. It would be nice if it can be a journal paper, for example, at the end. So your course report here will be something which can be published. So try to do something which is publishable using your PhD material or PhD dataset. So if you have a dataset, for example, if you don't have a dataset, just let me know, and I can bring you a dataset. If you don't have a problem to solve, just let me know. There are many problems which we try to solve, so I can try to help you to get a problem to solve. But the most important, at least minimum at the end of the course, to be able to submit a report, which consists of 6 pages, IEEE format conference paper, for example. So it could be something like a Springer format or IEEE format. Try to search for a conference, for example, where you can just prepare a conference paper, for example, from the course. So at the end of the course, if you will be able to get a conference paper or a journal paper, it will be very good. Some people, in fact, they publish journal papers in the course, and also some people also maybe can publish a conference paper or 2 conference papers. We will not restrict ourselves to get it accepted. It's just prepare it. So start by selecting a good title start with a template in overleaf, for example, for your paper, for example, and select a good title, good maybe abstract, introduction, background, materials and the methods, results, for example, and maybe discussions and concluding remarks at the end, and a reference. So try to build a paper or try to put your report in a paper format. So in this case, you will get your 7.5 credits. You will pass the course because grading in this course, we don't have AB grading, in fact. So grading here, it's pass and fail in the PhD level. So we don't have grades. So it will be pass and fail. And to pass the course, you just need to submit this course report in a paper format. And after the course, you can just submit it to any conference and you can get it accepted. So it will be good production in your thesis. So the idea here is to publish something in your PhD from the course. And we have maybe 14 weeks or 15 weeks. So just each week, try to write few lines, try to add a new section to your report. So at the end, it will be easy, very, very easy to deliver this course report. If you want to work in groups, it's okay. But in this case, we should expect more advanced work. So if you are working by yourself, we are expecting a certain amount of results, for example. But if you will work in group, for example, it's okay to work in group. So, for example, if 2 people are working in text, for example, maybe 2 people or 3 working in the same machine vision problem, for example. So they can team together, they can work together, but we should expect that they will deliver something more advanced. We should expect to see more work. It should not be compared to a single or individual person report. So if you want to work in teams, please try to make something more advanced because you have more resources in your team. So in this case, you should write a bigger report. Maybe it could be a journal paper, for example, and the results section should be more comprehensive. We have also a GitHub page. In this GitHub page, you will have links to slides. We have, I guess in my GitHub also, I put all the slides, PDF files, and also you will have also the slides and examples, all examples in those slides. You will find it in GitHub. If you want to search for datasets, you can get datasets from Kaggle, for example, if you don't have, but I'm sure that you have datasets in your PhD project. But if you don't have, you can try to search for datasets from Kaggle, for example. UCI also machine learning repository. It has also some datasets. So if you want to get more datasets. Blackboard. We have also Blackboard. So I will try to update Blackboard. So any announcements, I will put it in Blackboard, and also slides each day. Link. So if we have a YouTube link or something, I will upload it to Blackboard so people can watch it and they can get access to the slides immediately. But maybe I will do it after each lecture because sometimes I need to update something, for example. So it will be nice to do this. Course participant, this is not correct. In fact, this is from last year. So sorry about this. I will just skip it. Google Colab, in writing code, we will use Google Colab. And the Google Colab is a free and open source environment for Python. I like to use it, in fact, because it does not require lots of setup, and you can share code with other people. So if you are working in groups, for example, it would be nice to use Google Colab. But if you prefer to work in Jupyter Notebook in your computer, it's okay. This one is very similar. It's the same. And also, it's easy to share. So, but you just need to have a Google account in order to use Google Colab. And it contains the pre-installed packages such as Keras, TensorFlow, PyTorch, which are required for AI and machine learning developers. So it has all the stuff. It's rare, in fact, when you need to install something, but usually it includes all those packages. So it's a pre-installed packages. Also, in fact, when you are working with Google Colab, you can get access to some GPUs for free, in fact. So you can get access to some GPUs. And if you can make also subscription, in fact, so you can make a subscription and pay little money. And in this case, you will have access to much better computational resources. I'm using it for free, the free version, but maybe some people, if they have money in their research project, maybe they can just pay subscription, small subscription, and in this case, they will get access to more powerful GPUs. I mean, this is just a Google Colab. I want to give you a small introduction to Google Colab. If maybe I can just try to, but you can just start. I mean, I can try to give you this link for, it's just an introduction to Google Colab. For example, when you open it for the first time, you can go to File and just select a new, I don't remember effect. So new file, and you will open Google Colab and you can start working on it, for example. So it's very easy, and you can see it consists of blocks for text if you want to write some documentations or if you want to write some comments, and one block for the code. So you can write some text here if you want to explain things. So for example, I mean this code part or this section, we will do data pre-processing or something, because you will forget things quickly. So it will be nice if you can write some comments here, which will explain things to you. Even when you are working in your home assignment or something, you can just do it here. So you can just submit, generate a report from here, which includes text. You can add images also to that part. So it can consist of, it will be nice for, I mean, studying things or preparing some examples. And if you want to run it, you can just go to this runtime and run all, for example. You can run one by one, but if you want to run the whole code at the same time, you can just go to runtime and run all. So in this case, it will run all blocks in sequence. Also in runtime here, you can select runtime type. If you want to select a GPU, you can select it from here, in fact. So it's very easy to use. It's just here, it's a Google Colab exercise. So you can download this dataset from this UCI repository, for example. And this iris dataset, we will use it a lot, in fact, especially when we are working with a perceptron, because this iris dataset, it's a very simple dataset, and it's a very common to use in machine learning. In fact, this dataset, it is used for testing models. So if you want to compare between two models, you can just use a standard dataset for benchmarking. So this dataset was collected by Fisher in 1936, and it has 4 attributes. As you can see here, it consists of 4 columns. So the first 4 columns, A, B, C, and D, we call its input features. Those attributes are sepal length and width, and in centimeters, and beta length and width in centimeters. So we have those 4 columns, and it consists of 3 classes. So is a column number 5. Those are the classes. We call it target feature. So this one we can call it target feature, right? So this is the one which we need to classify, in fact. So here we have 3 classes. We have iris, setosa, versicolor, and virginica. So we have 3 classes. So if you want to build a model for classifying this problem using sepal length, width, and beta length and width, sepal length and width, beta length and width, it's when you look into the species leaves, you can just try to measure those width and length and width for the sepal and the betal, and you can just use those numbers for classifying each species into one of those 3 classes, setosa, versicolor, and virginica, for example. So if I want to build a model here, I can just say, okay, I have a perceptron, and this perceptron will has 4 inputs, correct? We will have 4 inputs because I have here A, B, C, and D. So this one will be first input, second input, third, fourth input, and after that we will classify into one of those 3 classes. But of course, perceptron, we cannot use it for 3 classes. We can use it only for 2. Because a perceptron can be used only for binary class classification, not multi-class. This problem, it's multi-class, right? So I can just use a model for classifying those species into maybe setosa and versicolor. I can say, okay, this model will classify only to setosa and versicolor, right? Because a perceptron, it's limited. This is the only limitation, in fact, we have in a perceptron. It cannot be used for multi-class classification because it has only one output. And this one output, it could be 0 or 1, for example. So I can just say, okay, when it is 0, it means it is setosa. When it is 1, it should be versicolor, for example. So don't have another option, right? We cannot have here another option. So we can use it for binary class classification. So in this case, We just need to modify this data set and maybe select the first two classes and use a model, a perceptron, and train this model to classify each species into one of those two classes, Setosa and versicolor. If you want to classify it for to Virginica at the same time, so maybe in this case we need to use feed-forward neural network. So the feed-forward neural network, it will has an output layer, and in this case we can just say, okay, we will have an output layer which has 3 outputs. So the first will be Setosa, the second will be versicolor, the third will be Virginica, and we will have here a hidden layer, for example, correct? And after that we have the inputs. How many inputs we have? We have 4 inputs, A, B, and C, A, B, C, and D. So in this case, we can just build a model, feed forward the neural network for classifying this problem. So the idea here, this data set is very simple and it's very smart because it will help us to understand many things. So we can use this one for training perceptron to do binary class classification, and if you want to use it for multi-class classification, so we need to move from a perceptron to multi-layer perceptron, right? So this data set is very simple and it's very nice. Yes, if you want to load this iris data set, you can get it from this here as CSV file. If you want to get as an Excel file, you can download it from here. And at the same time also, in fact, you can download it from sklearn. sklearn, it's a package in Python, which is used also in machine learning. So you can import it, you can download it from sklearn. I mean, you need to import the data sets from sklearn. And once you have these data sets, you just need to get iris or data from datasets to .load iris. When you write datasets.load iris, you will be able to download the dataset into this variable. And the dataset here, in fact, it will consist of 2 things. I mean, when you look into this iris, we will have something called iris data and iris target. Iris data, it's the input features, which is 4 column, correct? So from this iris data, it will consist of the A, B, and C, this sepal length and width, and the beta length and the width. So it will consist of 4 columns, A, B, C, and D. So this one will consist of, so this iris data, we call it X because X is the input to my model. So X will be iris.data. If you want to get the 5th column here, which is the target, we call it Y, for example, or classes. So it will be iris.target. So this one will be iris.target. So when you get the data, load iris, you can save it in any variable. We call it data or iris or whatever. And just remember that this one will consist of two variables. One variable, we call it iris.data, which is the input features, and the target features. And usually we store the input features in a variable called X, and we store the target features in a variable called Y. Because my model will be like this one. My model will be a block, and this block, the input to this block will be X, and the output, in fact, will be Y, right? So X here, it's a vector, consists of 4 values because I have A, B, C, and D. A, B, C, and D, correct? So maybe X here, it will be a variable of 4 values, right? And when I apply this one, I should get Y, and Y should tell me which class. Is it Setosa? Is it Versicolor? Is it Virginica? So this one will be class label. This one will be the class label. So my model will be like this one. So we will deal with all data in this course in the same way. So the most important, in fact, is this one is easy. In fact, this one is easy. There are lots of data sets which we use. We can get from sklearn or from Keras, for example, and we can play with it. But in fact, in your PhD project, I'm sure that your data set is in Excel file, correct? If your data set in Excel file, you need to learn how to deal with it, how to load it how to upload it to your if you will work with Google Colab, for example, how can you load it to your Google Colab or Jupyter notebook, and how to visualize it, how to play with it, right? So this is very important. So I will share this link with you. So if you want to open, I will put it in the chat. Sorry. Okay, I need to get. This. I mean, this is just a link for this example. I will share it with you in the chat, so you can just press it and play with it in the break, because we will take a break soon. I don't want you to get tired, so we will take a break, and after that we will continue working with this, but we will finish the slides first. So we will go back again to yes. So we will just finish that part first, and after, or do you like to take a break now? Do you want to take a break, or should we just continue? Hello?
Break will be fine.
Okay, so we will take maybe 10 minutes break, and after that we will start again. 10 minutes or 15 minutes? What do you want?
10 minutes maybe.
10 minutes,
Yeah.
okay.
Okay,
Yeah.
this is fine. So we will start again at 10:05. Thank you.
Okay, thank you.
Thank you.
Thank you.